In this topic, we are going to learn what is the periodic and harmonic motion. It means what is the periodic motion, what is the harmonic motion. So these kind of the fundamentals already we have seen our intermediate as well as in engineering mechanics subjects. So then what is the periodic motion, what is going to be harmonic motion? Just we have discussed about it, how the vibrating system is going to be excited. When we have given the external excitation that is converted in terms of the energy of that system, then it's going to be possess in terms of the potential energy or the kinetic energy, and mutually exchanging is going to be taking place. So in this case, I'm going to be read out the definition of that vibrating system. So the periodic motion. What's the periodic motion? As you know, the periodic means it's referred to the time, right? So then what is that? The motion of a vibrating particle or system which repeats by itself after an equal interval of time is known as periodic motion, right? And again I am going to be repeating the motion of a vibrating system. So here the motion of a vibrating particle or within the system that I am going to be draw here one vibrating system. That's by using the spring as well as the mass. So in this case what will happen? So I am going to be considering this is going to be the equilibrium position of the system. That is equilibrium position, EP I am going to be called. So then what will happen when I am going to be giving initial excitation to this system, that is the F force for the initial displacement, after that I removed. So then once you apply the force, then the same system will reach to this position. So the same system will going to be reach to this position, right? And I am going to be taking the axis of this member. So then it reached to the new position, then I am going to say this displacement is going to be the X we are going to be considering. So then what will happen in this case, once I am going to be remove this load, then this mass is going to be trying to back its equilibrium position. That means whatever the force you applied, that converted into the potential energy, the system started elongating. So that means from this position, the spring is elongated to this position, right? So that is going to be the deflection of the spring is going to be the X, or the motion, the path of that motion has taken from the mean position to the new position is going to be the X distance it is there. So then that potential energy increase, then it's going back. Once you remove the load, it will move up and downward direction until that energy goes disappeared. So that's what we are going to say, the motion of a vibrating particle, right? And this is going to be the mean position, up and down it is moving. So then which repeats itself after interval of time is known as the periodic motion. Once you remove the force, then it will start oscillating by itself until the energy is going to be dissipated. So then that we are going to say the equal interval is called the time period, because that motion is repeating by itself after certain interval of time, right? That interval of time, equal interval of time is called the time period. Or we can say that one, the time taken to complete one cycle of motion is known as time period. Is it clear? That means in this case, it will take time taken complete one cycle of the motion, right? And already we told that that's going to which repeats by itself an equal interval of time. That means this motion of the object is going to be moving up and downward direction. That same motion is going to be repeating. So then we can say that's going to be a time period, right? This way we are going to be defining the periodic motion. The periodic motion, the main function is that must be repeat that motion certain interval of time. We can say that's going to be a periodic motion. Just we have seen what's the periodic motion definition, right? And then the next one is the harmonic motion. The harmonic motion, what is the harmonic motion here? The harmonic motion is one of the form of the periodic motion, right? The harmonic motion is one of the form of the periodic motion. What is the periodic motion? That motion of a vibrating particle, the repeating by itself after certain interval of time is called a periodic motion. In this harmonic motion also, that system is going to be repeating its motion after a certain interval of time. That means it's completing the number of cycles is we are going to be saying. So then what happened? The harmonic motion is represented in terms of circular sine and cosine functions, right? So that's the periodic motion we have seen. But the motion we are defining in terms of the harmonic motion means here that we require circular sine or cosine functions, right? So then what will happen? How could you say? So as we know that the displacement of from the mean position to the new position is going to be the x distance is there. So then what will happen? From the mean position below is the x distance, from mean position to above is the x distance is there. So then how would you define that motion in terms of the sine and cosine values here? So then we can consider the motion of the type is going to be x1 is equal to a1 sine omega nt, right? As we know that, so that's going to be x1 a1 sine omega nt. As we know that x1 is going to be the displacement of the system, that's going to be, this is the part, right? And a1 is going to be the maximum amplitude it is going to be have. So in this case what will happen at the initial displacement, then what will happen, that system is going to be reaching to the maximum position. After the number of cycles, what will happen, that energy is going to be dissipated from that position observing to for that motion. So then what will happen, the same x displacement may not be visible. Then what will happen, the slowly it will going to be die out and it will comes to the main position. So then a1 is going to be the maximum amplitude of the system. Omega n is going to be the circular frequency of the system. So then what is the circular frequency? So that we are going to be defining the motion will be repeated after how much time it is going to be taking? That's the time period. We are going to be say that Tp is equal to 2 pi by omega n seconds. This much amount of the time taken to complete the one cycle of that system. So then all harmonic motions are periodic motion in nature, but vice versa is not always true. What is vice versa here? The harmonic motion. If the motion must be a harmonic motion, means that must be satisfy the periodic motion properties. Once it is going to be satisfying the periodic motion properties, then we can say that's going to be a harmonic motion. The system is vibrating according to the periodic motion. But all periodic motions are not the harmonic motions. So that is, we are going to say vice versa is not always true. So in this case, the harmonic motion we have defined in terms of the x1 is equal to a1 sine omega nt. x1 is the displacement of the system, maximum displacement of the system is the a1, and omega n is going to be the circular frequency. So then we need to find out the velocity and acceleration of that vibrating particle in a simple harmonic motion. So then what happened, that x1 by dt parameter I am going to be deriving, that is equal to a1 sine omega nt. What is the derivation we are getting? Cos omega nt. So then this parameter also we are going to be deriving, that is going to be omega n finally we will get it. That I am going to write it a1 omega n cos omega nt. So this we are going to be getting the velocity of that vibrating system. So next, acceleration, how could you calculate? That's going to be d square x1 by dt. That is equal to, what is the formula we are getting? As we know that a1 omega n is going to be the constant parameters, just we are keeping, and cos omega n we are going to be, the derivation is going to be minus sine omega nt, and omega nt is going to be the omega n. So that's I am going to say minus a omega n square sine omega nt. As we know that, so this is going to be the acceleration of this vibrating system. But we know the displacement, that x1 is equal to a1 sine omega nt. In the acceleration parameter also we do have a1 omega n square sine omega nt. If I am going to be replacing a1 sine omega nt with respect to x1, that acceleration of that particle is x1 is equal to minus omega n square into x1. So from this definition, it is going to be very clear that the acceleration of the vibrating particle is always proportional, directly proportional to the displacement of the system, right? And always moving towards the fixed point. That we are going to be say that the acceleration of the system harmonic motion. In harmonic motion, the acceleration here, can you see here, the x1, that means the acceleration of the particle, that acceleration of the particle x1 is directly proportional to the displacement of the vibrating system and always moving towards the fixed point. So this way we are going to be defining. So here, the harmonic motion, we got the acceleration of the simple harmonic motion of the particle. So that's going to be x1 is equal to omega n square, x1, that's going to multiply with the minus. So what's the definition? The acceleration of the simple harmonic motion is always proportional to the displacement. That means the acceleration of the simple harmonic motion is directly proportional to the displacement and directed towards the particular fixed point. So then what will happen? This is the reference point. So then what happens? It is moving up and down one direction. That is going to be acceleration directly proportional to the x1. This way we are going to be defining the acceleration of the system. So in this topic, we are going to be discussing about the superposition of harmonic motion or the addition of harmonic motion. In the last topic, we have seen what is a periodic motion, what is the harmonic motion, right? The harmonic motion is a part of the periodic motion. The motion of the particle, we define the motion of the particle displacement, we define in terms of the circular sine and cosine functions we have used, and we define that the system in terms of the sinusoidal equations. So then how shall we, addition of these two is possible? Suppose if you have a two kind of the motions of the system is available, so then what will happen? So in this case, the addition of, when you want to add these two kind of a simple harmonic motion, they must have the same frequency and they do have a different phases, right? So that's we are going to be discussing in this topic, and how we can add these two, and we are going to say the superposition of the simple harmonic motions. There, the definition here, when we add two harmonic motions, we are going to be adding the two harmonic motions, right, of the same frequency, right? They must have the same frequency, and we can get the resultant motion as the harmonic motion, right? So when we added the two harmonic motions which have the same frequency, the resultant, whatever the addition of these two, x1 plus x2, suppose the two displacement of the system having their different phases, then what happened? That resultant also we will get in the harmonic motion. So then we are going to say, let us have two harmonic motions of the amplitudes, A1 and A2. So then the same frequency is the omega, we do have the same, that's going to be omega, and we are going to be say, and the phase difference is going to be the pi is there. That's we are going to be defined that motion of a particle displacement, that's going to be x1 and x2. The x1 is equal to, already we told that the two harmonic motions amplitudes A1 and A2. With this one, I am going to be writing that equation. X1 is equal to A1 sine omega nt, and x2 is equal to A2 sine omega nt plus pi. So then this is going to be the phase difference between the x1 and x2 motions of the vibrating system. After saying that, the resultant also we will get in the harmonic motion. So then the resultant motion is given by adding the above equations here. So that's equations are going to be here 1 and the two equations we do have, that's going to be x1 and x2. So then x is going to be the resultant component of these two additions, that means x1 plus x2. Then what is the value of the x1 that I am going to be writing? X is equal to here, that's going to be A1 sine omega nt plus here A2 sine omega nt plus pi we do have, right? And as we know that this is going to be the resultant component of the simple harmonic motion when we add the two components here. So then what will happen? How it is going to be represented? That means we are going to be simplifying this equation. So then how we are going to be getting? This is going to be just like sine A plus B. As we know that sine A plus B is equal to, what is the equation? Sine A cos B plus sine B cos A. So we are applying the same equations for this part. So thus x is equal to, what's the formula? A1 sine omega nt plus A2, that's we are keeping in the bracket, that's going to be sine omega nt cos pi plus, this is going to be A part and this is going to be the B part. Then what happened? Sine pi cos omega nt. So in this case what will happen? So I am going to be simplifying this equation, then what will happen? That's going to be x is equal to A1 sine omega nt plus A2 sine omega nt cos pi plus A2 sine pi cos omega nt. So in this case we can see the sine omega nt, the sine omega nt is going to be the common terminologies. So that's, I'm going to be taking out that equation, that is going to be A1 plus A2 cos pi into sine omega nt plus, what is this one? A2 sine pi cos omega nt. So that we got it in this equation. So once we got this equation, I'm going to be simplifying this equation. That's going to be, and this parameter I'm going to be say 1, that's going to be assuming. I'm going to be assume here a1 plus a2 cos pi, that is equal to a cos theta. And similarly a2 sin pi, that's going to be a2 sin pi is equal to, that's going to be, what is the word? A sin theta. With these two assumptions, I am going to be simplifying this equation. How? What is the value finally we are going to be getting? That's going to be the resultant displacement by addition of the two harmonic motions. X is equal to a1 plus a2 cos pi. That's I am assuming that a cos theta. So that's I am going to be writing here a sin omega nt cos theta plus sin a2 sin pi. What I am going to say? That's going to be the a sin theta. I am going to be writing. That's going to be a sin theta cos omega nt. If I am going to be taking here, the a is going to be the common to the one side. So then what will happen? Sin omega nt cos theta plus sin theta cos omega nt. So this is the formula, just like sin a plus b. So that I am going to be writing here, that's going to be x is equal to a, that's going to be sin omega nt plus theta. So now you can see this is going to be a simple harmonic motion. Can you see what is the simple harmonic motions we got it early? That's going to be x is equal to a sin omega nt plus pi, or this is going to be. So the same it is going to be reflecting that one. x1 is equal to be, this is the x2. So by the addition of the two harmonic motions which having the same frequency but the different phase, then we will get the resultant components also going to be the simple harmonic motion. So that's going to be a is going to be the amplitude of the vibrating system, and omega is going to be the circular frequency of the resultant motion, and theta is going to be the, you are going to, what is that one? The phase angle for the resultant component. From the derivation we got that's x is equal to a sin omega nt plus theta. Alright, so then how could you calculate the value of a? A is going to be the amplitude of the resultant motion of the vibrating part, and x is going to be the resultant displacement of the vibrating system, and omega nt and the theta is going to be the phase difference of the resultant. So then how could you calculate the value of a? So then what will happen? I am going to be squaring and adding of the equation 4. In the equation 4 we do have the two equation, that's going to be a1 plus a2 cos pi, that is equal to a sin cos theta, and a1 sin pi is equal to a sin theta. So then if I am going to be multiplying, this one is going to be, so how we are going to be getting here, that's going to be a square cos square theta plus a square sin square theta. So that I have taken the right side of that equation, that is equal to a1 plus a2 cos pi whole square plus a1 sin pi the whole square. So once I am going to be simplifying this equation, I am going to be getting, that's going to be cos square theta and sin square theta. A is going to be the common, cos square theta plus sin square theta is equal to 1, that I am going to be writing. The a square is equal to, what is the formula this one? a1 square plus a2 square cos square pi plus 2 into a1 a2 cos pi plus a1 square sin square pi I am going to be taking here. So that's going to be here the value of, so in this case what will happen? So here I have mentioned here a1, this is going to be the a2 sin pi is equal to a sin theta. So then in this case what will happen? This is going to be a2 sin square pi, and this is going to be the a2 square sin square pi, the small modification here. So then in this case can you see a1 square cos square pi, a2 square sin square pi. So then if I am going to be taking the a2 square common, then what will happen here? Cos square pi plus sin square pi is equal to 1. So then in this case the final equation from this one, a square is equal to a1 square plus a2 square plus 2 a1 a2, and this is going to be the cos pi. So then further simplification, in this case the square term is there, that I am going to be taking to the right side of the system, then I will get in this way. So this is going to be this way. We are going to be finding the resultant amplitude of this vibrating system with the help of A1, A2 and cos pi. So these values we have seen for the initial displacement x1 and x2 terminologies. So then how could you calculate the resultant? So that means the resultant phase difference can be determined by the equation of 4. So from this equation, how could you calculate the theta value? So the theta value is going to be, how could you calculate? I am going to be dividing A sin theta this equation by this equation. That's going to be the A sin theta by A cos theta, that is equal to, what is the value we are getting? So that means A2 sin pi by A1 plus A2 cos pi. So in this case A is going to be cancelled out. Then finally what is that one? This is going to be the tan theta. So that's going to be tan theta, that's equal to A2 sin pi by A1 plus A2 cos pi. So then if I am going to be, then I can calculate the theta. Theta is equal to the tan inverse of A2 sin pi by A1 plus A2 cos pi. This way we are going to be calculating the principle of superposition of the two harmonic motions. So the same thing we are showing in the graphically. So then in this case what will happen, x-axis I have taken and the y-axis are going to be representing the magnitudes of that vibrating system, of the amplitudes. So in this case, as we know that x1 sin omega nt. So in this case the amplitude is making omega nt. That's going to be this value and this value I have shown. This is the magnitude of amplitudes of the A1. That means going to be the x1 displacement. And similarly A2, then we do have a phase difference omega nt pi. So in this case what will happen, this is going to be the A2 is the amplitude of the vibrating system that I am going to be taking from omega n, already we have shown. The total, this is going to be from A1 to A2, the phase difference is going to be the pi, that's we mentioned here. This is going to be the pi value. And similarly then we have derived that equation, A is going to be sin omega nt plus theta. The theta value already we have calculated. The tan inverse, what is the formula we do have? That the tan inverse is equal to, so A2 sin pi by A1 plus A2 cos pi. So that's value we can calculate it from here. So that's I'm going to be say here. This value is going to be already omega nt theta is there. So already omega nt value is available and this is the theta. This is going to be the resultant amplitudes of the vibrating system. Finally it is also possess the simple harmonic motion.